Remember that bonus question from yesterday?
Mm-hmm.
All right. Why was that bonus question like especially crappy? It was like a fraction, right? But also within there were things with negative powers. What is it about polynomials then? Can polynomials have variables with negative powers? No. So that's awesome. So if I'm working with polynomials, I'm not going to have any negative exponents because I'm not allowed to. That's nice. Let that be nice. So what do I mean? So if they say multiply a monomial times a binomial, I'm not going to have any negative powers. It's just going to be, can I add powers then? Because it'll be something like this. You ready? Okay. What's that? What type of polynomial is that? Monomial. Kind of gave it away. Why is it a monomial? Because there's no pluses and minuses. And here I got to put a binomial, so I'm going to have a plus or a minus in the middle. I'm going to make it a minus. All right, so take a minute and do that. Yeah. This is really nice. You don't need any FOIL business because there's only one term here. So bam, bam. It's just, can you consolidate all the A's, B's, and C's correctly? Alright, so what do you get here? We get
56, A3, B4, C3, minus.
Hold on. Alright. So far, so good.
Minus 14, A4, B3, C2.
Yeah, there are no more B's.
Yeah.
So there's still just 3 B's. And CC.
C2.
Alright, cool. So let that be nice when it's just straight up distribution. But I really want it to make sense now. If I put 7A cubed C plus B, that's FOIL, but that's really just distribution of each of those two things. They each get a turn. That only makes sense. That's only fair. But here's only one thing. So it's bam, bam, I'm done. Alright. Cool. Here, try this. This is example 1. Crouching algebra. Alright, so this shouldn't be too bad, right? What's 4xy times 4xy?
16, 4x2, y2.
16?
4,
X squared?
Yeah, x squared or y squared.
Y squared. So the 4's went together to make 16.
Sorry, yeah. Plus 28xy minus 28xy.
Yeah, but now negative 7 gets in so minus 28xy.
Minus 49.
Is everybody cool with what I got so far?
Yes.
And again, if you want to, you can kind of line your like terms up as you go or not. It's up to you. So I get, nobody goes with this guy. Aw. What happens here?
This one cancel.
And again, some of you guys might realize that this is what is called a difference of squares. Isn't everything in there squares? 7 squared, 4 squared, x squared, y squared.
So
A difference of squares. I know math people are very creative.
It's a difference of squares. There you go.
Okay, the name just came right to us. It was amazing. But do you have to know that right now? No. What I'm trying to do is when we get to the point where we're going to get to the point where we do this backwards. I give you this, and you have to figure this out. That's what's called factoring, of course. It's like taking 18 and breaking it up into factors. So we're going to get to the point where we have this, and we have to break it up into its factors. We have to undo this. So it's nice to know the form, because if you know the form, you know what to do. Okay. What about this here? Today's just a bunch of what ifs. What about if I gave you this? See if you guys.
25.
Nope. We know better than that. What are exponents based on?
Okay.
And is it multiplication in here?
No.
So you cannot just distribute it. It won't.
Well, then maybe just make it so
Beautiful. Something squared.
Yeah.
Like you said, something squared is it times itself.
Yeah. 5x
There you go.
minus 4 by 4.
So you write it twice, and then FOIL it. So I have two 5x minus 4s, right? So I say, okay, I have one 5x minus 4, and another 5x minus 4, and now it's just a normal problem. So don't try to shortcut that, because you're going to miss the middle terms. Poor little middle terms.
Done.
Alright, so what we got here?
25x squared minus 20x minus 25x squared 20x squared
Minus 20x.
oh yeah 20
Plus 16.
Good.
plus 16
Right. Cool.
this one minus
So notice how, okay, let's see. Notice how these were the same, but they had different signs. Because that was a minus and that was a plus, right? Here they're the same and they have the same sign because they're both, I have two that have a minus in them. So they're not going to cancel, they're not going to go away. They're going to build on each other, right? So I get 25x squared
Minus 48.
minus 40x plus 16. And again, anytime I do a problem, you could actually go back and say, well, what if x is 2? So let's try it. If x was 2, that problem's done. If x were 2, what number's inside there? What's this? 10 minus 4 is?
6.
Squared is?
36.
That's 36. This better be the same thing, or we got to throw math out. And you're all like... So if x were 2, I would have 25 times 2 squared, 4, minus 40 times 2, right? Plus 16,
so 100
100
minus 80
minus 80,
plus 16
20 plus 16,
36
36. So too bad for you, math works. Oh, son of a biscuit maker. I like. All right. Let's see. Last thing, and then I'll give you guys a nice spring break
yeah.
gift, right, for showing up. I should actually turn that off and tell you like some secrets or something. Let me see. Oh, all right. I'm going to do something that seems completely unrelated. You just got to go with me for a second. Let me see. I don't know if any of you have ever seen this. All right, real quick before. Right, it's like a pyramid kind of thing. I don't even know what it's called. I can keep going, so I want to see if you guys see the pattern already.
Yeah,
Yeah, what is the pattern?
it's
Yeah.
2, and then it'll be 3, 3.
Good. So I start with ones on the outside always, and then the 1 plus 1 is 2.
Yeah,
So then I put ones on the outside. 1 plus 2 is
3,
3. 2 plus 1 is
3,
3. And then I can go 1,
4,
4,
6.
6, 4, 1. It's called Pascal's triangle. And you're all like right now going, what's up? Come on. No, stop. Come on. The pattern here is not difficult.
Yeah.
How did I get that 3? I added the 2 numbers above it.
Yeah.
How did I get that 3? I added the 2 numbers above it. And I keep putting ones on the outside. That's the pattern. So how do I get the next line? Put the ones on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4.
Just for one.
Now, I'm not asking you if you know why I'm doing this. I'm just asking you, do you see how I came up with these numbers?
Yes.
Okay, good. So don't freak out about, I don't know what the hell that's for. I haven't told you yet, right? We're not going to use this. I just want to point this out. It's really kind of neat. And of course, 1, 5, 10, 10, 5, 1. I mean, you can keep going forever. It's a little insane. You're like, all right, some dude that was bored did that. Yay for him. But now watch this. Go with me. Watch. I'm going to do 2 problems. So this one, we just did one like this. What do I have to do first on this?
Write it twice.
Write it twice. Don't worry about it. We'll do it. Yeah, exactly. Exactly. And then to do this, this is relatively easy, right? What do I get?
X squared.
X squared.
X plus X plus 1.
So I get x squared plus 2x plus 1. Can somebody tell me what all the coefficients are? What's the coefficient here?
1.
1.
2. 1.
Okay. Jeff, good point. What did you just say? What did you say? How do you do this?
3 times.
What are you doing? Okay. Everybody see something interesting? And real quick, there's no way in hell you can do all 3 of these at once. You can't. If I said, what's 2 times 5 times 3, you cannot just, bam, get them all. What do? You do 2 times 5, and then times 3. So when you have this kind of problem, you do this. Didn't we already do that? All right, so let's just put, I do this, and the result,
with this.
I multiply by that. So what do I get here?
X squared
Yeah.
plus 2x plus 1.
Now I'm going to multiply by that. Right?
Yeah.
All right, let me stop there. Is everybody kind of with me? When you have something cubed, you write it 3 times. We just happen to already do that there. So I'm going to put the answer there.
Why didn't you distribute it instead?
I did. What would I do here? What would I do? I would do exactly what we did here. We already did it. Didn't we? So I just took the answer I would get and put it there. Now what am I going to do next?
Distribute.
Distribute. X squared times x.
X cube.
X squared times 1.
X squared.
And here's something, and when you put the bigger dude in front, this kind of is neat how it happens. The like terms line themselves up. Watch. Now it's 2x's turn, right?
Yeah. 2x.
2x times x.
2x squared.
See my x squares are together? 2x times 1.
2x.
Now it's 1's turn. 1 times x.
X.
And 1 times
plus
1? Now collect your like terms. X cubed plus 3x squared plus 3x plus 1. What are the coefficients?
1, 3, 3, 1.
Holy shit. So if I did x plus 1 to the 4th power, those would be the coefficients there. 5th power, 6th power. That's the power of that. We're not going to use that in this class, but I want to show you that exists. It's really neat. And what seemed like somebody was bored and just started doodling and just started putting numbers together has an immediate application. There's a shortcut in there somehow. I'm not going to make you know it. I'm not going to actually talk any more about it because I want you to be able to do this. Right? But it is neat that exists.
They call it.
Pascal's triangle. So Pascal did a lot of stuff. He's one of our great mathematicians from days of old. We actually named the computer program after him that I learned right before they started teaching C++. I was like the last people to learn Pascal. Yeah, Visual Basic. Yeah.
So if in the x plus 1, if you change the 1 to 2, it would be the 4 row?
No. It's the power that tells me what row I'm at. It's right. If I'm a squared power, then I'm on this row. If I'm a cube power, I'm on that row. Now, there's a lot more that goes into. Notice how both of these have an exponent of a coefficient of 1. So if there's anything else, there's more math behind the scenes here that you have to worry about. But the coefficients would still be these. It's determined by the power. I'm on the row with the 3s.
Even the x and the 1 change?
Totally. All right, this will be the last thing. And this is definitely not something we would do. I really want you guys to get so if I did this, real quick, stay with me. What happened to the x's as it moved along? Here I had 3 x's, and then the next time I had 2 x's, and the next time I had 1 x. Do you guys see that?
Yeah.
All right. So here's the shortcut. I'm on the row where I'm supposed to have these coefficients, right? Because it's a cube. Again, I'm not teaching you this really, but I just can't stop because I love this shit. I'm sorry. It's nothing you're going to have to do. In fact, I almost don't want you to do it this way because you have to know how to FOIL stuff and distribute. So what happens is I start with all x's and no 2's. So I have 1x cubed. 1x cubed plus 3 times, now I have 1 less x and 1 more 2. Plus 3 times, now I have 1 less x and 1 more 2. Plus 1, and now I have all 3 2's. So I have all x's, a mixture, and then all 2's. If you don't understand that, that's completely fine, because you don't have to. What you asked, I couldn't stop myself. So then this would be x cubed plus 6x squared plus 4, 3, 12x plus 8. So if you actually wrote this 3 times and did it, that's what you'd end up with. I am not requiring you to understand this. It's just neat to see some of the shortcuts that would create when we get higher up in math. Because if I have it to the 10th power, screw this. No, I'm not going to do that shit. So we developed a shortcut because we saw the patterns. That's enough. That's enough for today. All right. Yay. Yeah, they already had parades and stuff last weekend. It's crazy.
Do you teach anywhere else?
No,
Oh, so you don't.
thankfully.
Yeah.
I'm a full-timer here.
My English teaches at Palomar. He says that this week, next week is not their spring break.
Oh, yeah. Well, we finally made our spring break. It used to be tied to Easter Friday.
Yeah. Good Friday.
What is it, Good Friday? And now we made it always in between the 2 8 weeks. It's always going to be there. So anybody who teaches 8 weeks, you got a week like to adjust for the next 8 weeks. It's kind of nice.
Will you teach 90 next semester? Fall?
No.
No?
I can't remember actually off the top of my head. I can't remember if I took 88 or 90.
Yeah, somebody asked me about your schedule next semester, so...
I have my schedule for next semester, I just can't remember
Okay, I will
off the top of my head. I think I am teaching 90.
90?
Because I think I picked everything with zeros, but maybe not. There's a good chance I took an 88
I
instead.
will email it.
Oh,
No, that's not.
let me think. Elijah, do you have that? I gave out this thing?
I do.
So,
Can you get it?
Yes.
Yes, that'll help me.
Wednesday, and I'll
What's up?
Can I get your YouTube thing?
Oh, yeah. Do you have the syllabus?
No. All I have is
Alright,
I
so
don't have fingers.
if you go to YouTube, you can search for Waller is me. Waller is me, one word, right? Or you can go to to my website, and under 90 there's a link for videos, and it'll take you to the YouTube page.
You have a website?
Yeah, yeah. So it's on the syllabus.
Okay, yeah,
Is
sorry, I should
Grossmont,
PDF on my phone.
and then it's people, and then it's freaking Jeff Waller with a hyphen. They made it so hard to get there, right? But it's my name with a hyphen. Grossmont, people, Jeff Waller.
Grossmont, what is PDU?
Yeah, just go to Grossmont's website, tack on people and Jeff Dash Waller.
Okay,
Yeah.
thanks.
Oh.
I have a question for everyone to ask about